We're getting ready to start the fourth section in chapter 3, Properties of Logarithms. I don't know if you can tell very well with the way it's printed out, but I had realized that instead of logarithms, I had written the word exponents. I erased and put down logarithms, and I thought, well, it's about the same. Logarithms are exponents, so it kind of would have applied. And we're going to go over some properties here, and then we're going to look at some examples, because we want to be able to use these properties to either expand or to condense logarithmic expressions. The first one here, the product property of logarithms, that says let b, x, and y be positive real numbers, b not equal to 1, and log base b of a product, x and y, is equal to the sum of the two logs, log base b of x plus log base b of y. And if you kind of think about this in terms of exponents, when we have the same base, and we have the same base here, when we are multiplying exponential expressions that have the same base, we add the exponents. So it goes right in line with that. Write the logarithm as a sum and simplify if possible. So using this property, do you see the two factors, the x and the y? I'm going to break this apart to log base 4 of 16 plus log base 4 of d. Now, it says simplify if possible. That's right here. Because if you look at this, 16 can be thought of as 4 to the second power. And I have plus, oops, almost put that base a little too high. And log base 4 of 4 to the second power, from the basic properties that we discussed already of logarithms, is 2 plus the log base 4 of d. And that would be my answer. Now you say, well, what if I don't pick up on this? What if I don't see that this is equal to this? Well, you probably miss it if it's a multiple choice question, and you probably would get partial credit at best if it was a free response. Let's look at the next example. Notice no logarithm base is written down, so it's understood to be 10. This is a common log. And I have 3 factors here, so what I'm going to do is I'm going to write this as the log of 12. I'm just going to kind of expand this property here. The log of 12 plus the log of c plus the log of d. All right? Quotient property of logarithms. Let b, x, and y be positive numbers, b not equal to 1 again. This time, for a quotient division, notice dividing here, that the log base b of x divided by y is the log base b of x, the numerator, minus log base b of y, the denominator, or the divisor. And again, let's think of this in terms of exponents. If we have the same base and we're dividing exponential expressions, we keep the base the same, we subtract the exponents. We subtract the exponents. So this again falls right in line with properties of exponents that we've had in previous chapter. Let's try an example over here. Write the logarithm as a difference of the logarithms and simplify it if possible. This is assuming that t, because we have t right here, this is assuming that t represents a positive real number. Well, base 6 here, I'm going to write this as the log base 6 of 8 minus, if you can see it still, minus here, the log base 6 of t. Now I cannot write 8 conveniently as 6 raised to a power, so that's as far as that one would simplify. Over here, very similarly, natural log this time. This is the natural log of the numerator minus the natural log of the denominator. Now this one I can simplify it a little bit, because the natural log of e, this is a base e logarithm, and this is e to the first power, so this is just 1 minus the natural log of 12. And that's as far as that one will simplify. Okay, a third property, which is really just kind of an expansion of this first one with the product, is a power property of logarithms. Now if you put these 3 properties together, in a lot of textbooks they call them the laws of logarithms, and they're very important to know when you're doing this type of work with logarithms. the power property of logarithms says let b and x be positive real numbers, b not equal to 1, and let p be any real number. That the log base b of x raised to the power of p. Now notice it's raised to the power of p. That this is equal to p times the log base b of x. Now, let's just kind of think about this in a very simple way. If I have the log base b, let's just make it x to the third. This is the log base b of x times x times x. This is the log, using the first property, the log base b of x plus the log base b of x plus the log base b of the third x there. And 1, 2, 3, I have 3 of them. This is 3 log base b of x. See how it's as if the exponent comes out in front as a factor, as a constant factor. So this is also a very good one to remember. And I'm going to apply it here for these two examples. Apply the power property of logarithms. Now, I can't really apply the power property yet in this first example because of the way it's written. I am going to rewrite the fifth root of x to the fourth expression. I'm going to write that as x to the 4/5. Now I'm going to apply the property, bring the exponent out in front as a constant factor of log base 5 of x. This one's a little bit more direct. It is a natural log, but it would work for any base log. I can bring the 4 in front and write that as 4 the natural log of x. So you'll need to remember these three, and I'm going to use these three to write these two expressions that I have over here and kind of expand them into like separate little logarithms here. So the first thing I'm going to do on this example here, I have the natural log. It says write the expression, this is sum or difference of logarithms, of a to the 4th b all over c to the 9th. That's a 9 there if you can't see that very well. This is the log, or the natural log, of the numerator, a to the 4th b, minus the natural log of the denominator. This right here is a product, so using property 1 here, I'm going to write this as the natural log of the first factor plus the natural log of the second factor, minus the natural log of c to the 9th. Then I'm going to use the power property here because I have exponents, and I'm going to bring those out in front. I'm going to write this as 4 the natural log of a plus the natural log of b, minus, bring the 9 out in front, 9 times the natural log of c. Now I usually have students that will say, well, why would I ever want to do this? Why can't I just work with here? I just plug in, I take the natural log. Well, my go-to answer is that in calculus, you're going to be taking what's called the derivative of an expression like this. And the derivative of that expression is going to be a little complicated if you leave it in this form. It's a lot less complicated if you write it what I call expanded form there. Okay, I'm going to do one more here. First thing I'm going to do is I'm going to write this cube root as one-third exponent. Okay, so the cube root of this expression is this expression raised to the 1/3 power. Then I'm going to use the power property. I'm going to bring the 1/3 out in front. Yeah, I'll use brackets this time because I have some parentheses. Okay, now I'm going to use the quotient property. Now, watch what I'm going to do here. Because I'm taking, and I'm going to break this into two terms, I need to bring the 1/3 out in front. So this would be the log base 5 of the denominator, or excuse me, of the numerator, minus the log base 5 of the denominator, a squared plus b to the second power. All right, now I'm going to distribute by the 1/3, and as I do that, I can kind of see with the log base 5 that 25, that's just 5 squared. So I can use one of those basic properties here of logarithms, minus 1/3 times, now notice here, I have a 2 that I can bring out in front, times 2, the log base 5 of a squared plus b, that's that power property. Well, this is just 2, so I have 1/3 times 2. This is 2/3 minus 2/3 times the log base 5 of a squared plus b. Now, of course, this is 2/3, minus 2/3 the log base 5 of a squared plus b. Be careful here. Common error in dealing with logarithms is that students start trying to separate this with a sum. You can separate the product and the quotient into sums and differences respectively, but you can't separate this sum. The log of x plus y is not the log of x plus the log of y. So this is as far as this one simplifies.